Okay, so welcome everyone to this new webinar from the space think tank of ENAC alumni. So my name is Nicolas Soulard, and with Maëlie Beliazi, we are going to present this webinar with our two guests, Ahmed BOUKABARA and Ousmane Si. So first, a little word about this space think tank. So it was in 2019 that Maëlys and I were students at ENAC, and during our last year, we did our master thesis at CNES, and we realized that we were probably going to work in the space sector. While when we arrived at ENAC, it was we were expecting maybe working in the aviation or aeronautics sector and not the space sector. So we realized that ENAC was a good place to learn about space-related subjects, and we wanted to encourage people into following this way. So we created this think tank, and we have some activities every year. Every year in February, we are doing a little conference for the engineering students who are in the first year, and with other alumni who work in the space sector, we present our work, our jobs, and how did we get to this job, like what did we choose as options at ENAC, like which majors, which minors, and which internships, and we give some advice on how to process to work in the space sector after ENAC. We also organize some afterworks, usually in Toulouse and in Paris. And as you can see, we are also organizing webinars. So this is actually the fifth webinar we are organizing. We had the first one where we presented ENAC alumni who created their company space sector. We had another one about the opportunities at the European Space Agency, like internships, jobs, and everything. Then we did another one with 4 alumni who are working in the space sector, and a last one about Galileo for civil aviation. So you can find all these webinars recordings on YouTube, on the YouTube channel of ENAC alumni, if you're interested. And today we're going to talk with 2 of our alumni who now work at NASA. The American Space Agency is really famous, and we wanted to have a testimony of their experience and how did they manage to get a job there. So first, let me present our 2 guests. So we have with us Dr. Ousmane Si. He's a remote sensing engineer. He got his diploma in 2003 and his PhD in 2009. And he then joined the Jet Propulsion Laboratory at NASA to work on atmospheric radars and mission concepts. And we also have with us Dr. Sid BOUKABARA, who is a senior scientist at the Earth and Science Division in NASA's Science Mission Directorate. And since 2023, he has been a member of this directorate, and his job consists in supporting the directors at NASA Earth Science Strategy and working on the multi-agency collaboration efforts. So we will start by letting our 2 guests present themselves for about 10 minutes, and then we have some questions for them. And at the end of the webinar, you will be able to also ask the question you have for our guests. So the floor is yours. Who wants to start?
I can start. First of all, thank you for the opportunity. Thank you for inviting me. And bonjour tout le monde en ligne. J'avais hésité à faire la présentation en français, puis je me suis dit que les expressions vont venir plus facilement en anglais. So we decided to do it in English. Let me share my screen. I have a few slides just to give you a quick overview of my background, and I hope that's what you had expected, Nicola. Let's see. No screen. Can you see my screen?
Yes, it's okay.
Okay, so I'm not going to try to put it in slide mode. It didn't work when we tried it before. So I am Ahmed BOUKABARA, a Senior Program Scientist for Strategy in the Earth Science Division, like Nicola was explaining. So I divided this into three parts of my bio. Part one is just a quick background of where I'm from. I'm from Algiers. So this first part is how did I get from Algiers to Toulouse? I grew up in the Algiers suburbs with public school teachers' parents. 19 years old, I moved to France, Toulouse, to study ENAC in 1991. And I finished my engineer degree in 94 with a specialty of electronics and specifically signal and image processing. At that time, I don't know if it still exists, but there was a great opportunity to do at the same time a master degree at the Institut National Polytechnique de Toulouse, which I did in 94. So that opened the door to actually making it easier to do a PhD. And this is a picture that I really liked of Toulouse, the Ville Rose, taken in 1992. And I had a chance to go there recently, and it's still almost exactly the same. It hasn't changed by one bit. This is also another picture of the group, in the hope that maybe some of you can recognize themselves. This is a long shot, but I just put it there just in case. That was a great 3 years in ENAC. More specifically, this is another picture of the group, and this is a picture of me and two of my friends there, Alexis and Amirouche, and we still kept in touch all those years since 94. All right, the part two is how did I get from Toulouse to Boston? And I had a stop in Paris in the meantime. So at that time, for my internship, I couldn't secure actually an internship in what was at that time the desired places like big private companies, Airbus and so on, because they required French citizenship, which I didn't have at that time. Instead, I was offered actually an internship at a public institute, Centre d'études terrestres et planétaires, CETP, which I understand doesn't exist anymore, unfortunately, but it was merged into another entity. And that was really a transformative and excellent experience that really opened the door for me to the space field. So that led me to pursue a PhD. They offered me to pursue a PhD in that I got in 1997 from Paris 7, the Denis Diderot University, in physical methods in remote sensing. And the thesis at that time was synergy of active and passive microwave observations to enhance remote sensing of the atmosphere and the ocean. The irony there is that my scores in microwave classes in ENAC were terrible for some reason, and I ended up actually working in microwave for many years in my career. So that your scores don't necessarily mean a lot in the long term. So while I was doing my PhD, I actually was sent to Boston for a conference. So my thesis advisor sent me to present a poster there. And I ended up meeting Dr. Ross Hoffman from a private company in Boston, who had actually a proposal to NASA that had exactly the same topic, so synergy of active and passive microwave sensors. And he asked me if you're interested, and if I get funded, then you have a job here. So I went back to doing my PhD and not thinking too much about it. Then his proposal got funded, and the rest is history. I went back and started working in Boston, thinking for just 1 year. This is another picture with my friends doing hiking in the Pyrenees around Toulouse while studying. Very good friends. We stayed in touch for a long time, for many of them. All right. And then, so when I went to Boston, my path there to Washington, I ended up spending 7 years in Boston before going to Washington. And that started in 1998. And I had 3 kids. I was thinking I would stay there for just 1 year and ended up staying 7 years and having a family there. I worked in a company called Atmospheric and Environmental Research, and they had contracts with NOAA and NASA working on the next generation satellites. At that time, they were called NPOs. And then I moved to Washington. It was a natural move because Boston was too cold for me, as you can imagine, coming from North Africa. Boston with the snowstorms and so on was very cute in the first few years, but it got on my nerves after a few years. So I was thinking moving south, and Washington, D.C. was the right place because going further south, that's Miami with all the hurricane issues and so on. So Washington, D.C. offered the best compromise there. I became first a contractor in 2005, and then a U.S. citizen and a federal employee at the same time in NOAA in 2007. And I became the deputy director of the U.S. Joint Center for Satellite Data Assimilation in 2009. Worked 18 years in NOAA until last year, where I joined the NASA headquarters in April 2023 as a senior scientist for strategy. So a quick last slide here to describe my work in NASA headquarters in DC. I do strategy. So what does it entail? Basically, you take stock of all your expertise, the technical expertise, but you take it at a higher level. So there is a big sense of humility because at that level, you don't know all the details. You don't know all the aspects that you haven't been exposed to. You work a lot on exploring partnership across sectors between the governments, the private sector, across disciplines, between, let's say, aerosols remote sensing and ocean remote sensing and atmospheric remote sensing and satellite calibration. So there is a lot of partnership across sectors and across disciplines. It requires an inquiring mind, so you have to be very curious to really understand what different disciplines are about and what is important for them, what are the challenges. NASA has multiple centers, so we have to always work across centers and do outreach to the different teams with their different expertise. There's a lot of analytical thinking and crossing the dots and connecting the dots between different things that are going on. And I would say one of the major aspects of my job is predicting issues. What are the issues coming up and what are the opportunities? So keep an eye on the opportunities. So there is that push and pull aspect. What are the challenges that we have to address and what are the opportunities that we need to take advantage of? And out of that, coalesce thoughts and ideas with others and coming up with recommendations on how to go forward on aspects with strategic long-term value. And I will stop there. I hope I covered what you had expected, Nicola and Maëlys.
Yes,
Great.
Thanks a lot. Thank you. Maybe we can. I just wanted to add a precision. So you talked about the NOAA for the non-US people. Maybe it's not super clear. So maybe you can explain quickly what is NOAA and the difference with NASA.
Yes. Thank you for reminding me of that. Yes, the National Oceanic and Atmospheric Administration is the U.S. government agency that takes care of issuing warnings and weather prediction and ocean predictions and so on. So they have their own operational satellites. I was going to say it's perhaps the equivalent of Météo France combined with the operational version of CNES. CNES is more research. NOAA is more operational satellites. So that's the difference. So NASA is more on the research, NOAA is more on the operational side.
Okay, thanks a lot. Ousmane, if you're ready.
And just to say one thing for the audience, if you already want to start asking your questions for Sid or Ousmane on the chat, you feel free to do so from now until the moment when we actually give you the floor for questions. You can already start putting them on the chat. Thank you. Go ahead, Ousmane.
So can you hear me?
Yes, we can hear you well.
You see my screen? Oh, yes, I think you do. Perfect. So first of all, I just wanted to thank you for the invitation. It's really great to be back, even though virtually at ENAC. It's a place that is really near and dear to my heart because of everything that I was able to live there, the people that I met, and so on. So I'll go through take a slide, slightly more than Sid Ahmed. And if it's too long, just cut me through and I'll just stop. Part of the class of 2000. IENAC 2000. I majored in electrical engineering and took a minor in electromagnetics or microwaves. The last year, same as Ahmed, it was a great opportunity to go and have an extra degree in microwave and optical telecom, which I received from the University Paul Sabatier. While on campus, I was quite active. I was part of Ingénieurs Sans Frontières, which is an association where I got to go and work with people at SUPERO and INSA on projects that have to do with improving the conditions of people around the world using engineering skills. I was also part of the Club Sono. I'm sure it's still up and running. And I did quite a bit of sports, mostly in the second teams in basketball and football. I tried to look for a picture of myself back at ENAC, but I couldn't really find one, at least a good quality one. But instead, I remember that whenever I meet someone from my class, they bring up this date, so May 31st, 2002. For those of you who do not know, that was the first day, the opening day of the World Cup. And mighty France, that had won actually the World Cup and the Euro Cup, would be meeting Senegal. My mother is from Senegal, and it was our first participation. So I'm sure that no one from that time is listening, so I'm going to tell you how I prepared myself. So my idea was, okay, if we lose, I would come up with an excuse like, the most important is to participate, l'important c'est de participer. We were close, maybe next time. And if we drew, so if you have 1-1, 2-2 or anything, I would be bragging like crazy. And it turned out that Senegal actually won. So I celebrated it like crazy. And to this day, whenever I meet people from that time, they remind me of, oh, you remember how you almost lost it that day? 2002, I did something more than just celebrating this game. I also did an internship at Astrium in Toulouse. And the topic was to study solar cells that they use on spacecraft and to see how you could improve their efficiency. So there was a little bit of electronics and a little bit of optics. And that ended up being an awesome thing for me because I really needed to have a practical application to everything that we were seeing at ENAC. In the third year, I did my internship at ONERA, still close to the campus. And there I was studying the impact of lightning on structures such as aircraft. So you can see it actually on the cover of my thesis that is shown here. Great experience. And out of this, I just wanted to see what I could do in the real world with everything that I had learned. So I ended up working for a company called Assystem in Toulouse. And they sent me to I actually carried out several missions. And that ended up being a great thing because of the diversity of things that I got to do. So the first one was what we call a thermal vacuum campaign, or TVAC. We were testing a telecom satellite built by Eutelsat that would be launched in 2004. So before its launch, you need to make sure that it will withstand, the changes in temperature and so on and so forth. So it was a great month and a half of experience. And the nice thing is to see the device you've worked on launch. The funny story here is that initially it was supposed to broadcast TV and radio over Europe and the Middle East. And somehow for the past 2 years, they moved it to North America. So I'm kind of getting the feeling that the satellite is following me around, but that's just my personal feeling. The second mission that I did was at Airbus. I was actually in the, I think they called it the lab back then. And what we did was actually to test several types of avionics systems. So in my case, I was focusing on ADIRS, which are air data and inertial reference systems. So pretty much as I'm showing it here, it takes an input from a bunch of sensors to generate information that is sent to the top cockpit. And the box itself looks something like this. So it was a very interesting experience because already going to Airbus and knowing that you have to walk between airplanes to get to your office, that's really a thrill. And now what I'm saying is really personal, but personally, I just needed, in fact, to get back into research. So after about 8 months, I just started looking for a PhD. And that ended up being extremely difficult in France. And the reason being that many people actually objected the fact that I should have done a PhD straight after my DEA or straight after ENAC. And instead, I went to work. So that was something that I wasn't expecting, but that led me actually to the Netherlands. How did I end up in the Netherlands? It turned out that when I was finishing my internship at ONERA, the presentation that I gave was attended by someone who had studied with someone from the Netherlands. So when he heard that I was looking for a PhD, he told me about this opportunity, and that ended up being an amazing thing. So for those who don't know, actually Eindhoven is in the south of the Netherlands, as I'm showing here. And you can see that it's really at the crossroads of many countries. So you're really close to Belgium, really close to Germany, Luxembourg, and the north of France. And that actually leads to a very dynamic environment in which I was able to live for 4.5 years. Before going there, the only thing I knew was PSA. The only thing that I could think of when you mentioned Eindhoven was PSA, because we would often see them at the Champions League. And it turns out that the P of PSV stands for Philips. So in the same way that you have Aerospatiale and Airbus that lead to a very dynamic environment in Toulouse, the same holds for Eindhoven, where you have a lot going on in terms of electrical engineering research and also a little bit of optics. The university itself is quite big. We have 14,000 students, of which about 1,300 are in a doctoral program. So that's really great because it means that when I got there, there was already a structure that was ready, in fact, for doctoral students. A bunch of departments. The university is part of several networks, which is great. And a picture of the campus is shown here. And the topic of my PhD was actually to use statistics to study electromagnetic interactions. So if you don't mind, I'll just give you a little bit of background on it. So I worked in a specific area called electromagnetic compatibility. So what it means is that you try to build systems and make sure that those systems can coexist with other systems peacefully. And the idea there is that when you're dealing with something that is super complicated, such as the image of this spacecraft, or this aircraft carrier, where you cannot claim to know everything that is going on, you can just assume that what you do not know varies randomly. So by assuming that what you do not know is random, it allows you to pretty much use probability and statistics to compute meaningful information out of it. So that's what I got to do. It was a great time, honestly, a great time. I got to work with amazing mentors, and they had a role by which if you do the work, you present the work. And that was really something that was amazing. It allowed me to travel to the US twice, to Italy, Finland, and even Switzerland. All this was made possible by the support of ONERA, who was actually funding one of my advisors, and also by the support of the Dutch Ministry of Economic Affairs. The campus was also great because you had 2 centers of excellence. The first one is URANDOM, and as the name indicates, it's a center of excellence for probability and statistics. And the other one was the CASA Center, where they do computational analysis. So a lot of math, a lot of applied math. And it ended up being a great thing because just by sitting in presentation, I would be getting so much information that I could use for my research and so on. And also living in the actually going into research actually involved ups and downs. So there are times where what you're doing simply does not work, and it is part of research. But the thing that really helped me was that I knew that I had chosen this path. So whenever things were getting a bit rougher, I just reminded myself that, okay, you are in this situation because you chose it, and that really helped me go forward. Living in the Netherlands was also great because I got to learn a new culture, a new language, and also a new educational system. So one of the odd things is, of course, that you get to write your thesis as a book. So this is pretty much the cover of my thesis. The other thing is that the PhD defense itself only lasts 1 hour. And if you look at this picture, which is the picture of my defense in 2009, the gentleman here that you see holding a stick, his job the day of the defense is just to keep track of the time so that the defense does not go beyond 1 hour. So that's one thing that is pretty specific. And the other thing that was very special about this day is that it allowed me to present my work in front of my family and really good friends. So one of them is not shown on the picture, is Paul, who was there with his son. I really, really thank him for being there. And the other 2 who are prominently featured here are Pierre-Yves and Mehdi, who were both classmates of mine. It was really great to see them, and they even agreed to wear the costume à queue de pied for me. So for that too, I really thank them a lot. So I spent overall 4 years during my PhD, and at the end of that, I just needed to get back into aerospace. The reason being that after my PhD, the natural progression would have been towards academia, or maybe towards Philips, and I really was itching to get back into aeronautical or space industry. The other reason is also that I was a little bit tired of the rain because it rains quite a bit in the Netherlands, and after 4.5 years of collecting buckets of water, I was like, okay, I need to get something a little bit warmer. And after a few applications, I ended up being accepted at JPL. So JPL stands for Jet Propulsion Lab. We're located in Pasadena. You have an image of the campus here. As you see, it's pretty green. We're up in the mountains. There's about 6,000, more or less 6,000 employees. So it's a relatively big center. And the main mission of the center is to explore the universe using robots. So you see it through the Martian rovers that have been sent over the years, but you also see it through the probes, the Voyager probes that were launched in the 70s and that are still going. So those to me are really fascinating feats of humanity as a whole. There's another very specific feature of JPL, which is that it is actually managed by Caltech. So it belongs to NASA, meaning that my desk, my computer, everything that I use belongs to NASA, but I am actually under the management of Caltech. And Caltech itself is a university that has around 2,300 students, of which 1,400 are in postgraduate. And the other very specific thing is the number of Nobel Prizes that come from there. So they've had over the years about 79 Nobel Prizes, and of which 47 are either alumni or faculty. So it gives you an idea of how dynamic the center is. And the other specific thing about JPL is that most of us are actually university employees. So in my case, during my postdoc, and even now, I'm an employee of Caltech, but in between, I also spent a year at UCLA. I joined JPL actually to work in the radar science section and to work on atmospheric weather radars. So why do we study the atmosphere? And especially why do I study clouds and precipitation? Because they contribute to the transport of water from the surface to the air, to the sky and then down. And they're also important for the energy cycle because having clouds limits the amount of sunlight that you get, so the amount of heating that you get at the surface. But on the other hand, it also traps the infrared emission that comes from the surface. And that is an effect that people are still trying to model accurately in model. And for all these reasons, we need in a way to get measurements of precipitation and of clouds. And that's where radars come in handy, because with radars, you're able to see through the target that you're looking at. If we have some time, I just wanted to explain a little bit the distinction, because the radars that we see at ENAC are a bit different in the sense that you're looking at the solid targets. You're trying to detect an airplane. In our case, we're looking at clouds. So it means that even when you get a first echo from the cloud, you'll keep getting several echoes afterwards because the signal keeps traveling through the cloud. So it means that if you collect all of those echoes, you're able to get a profile of the cloud that you're looking at. And this type of device exists underground. So these are actually Nextra radars, I think that belong to NOAA, if I'm not mistaken. The great thing about it is that it allows you to build mosaics such as these ones that give you an idea of the storms around. As we all know, we have also radars in the nose of airplanes, but the information that they give you is a little bit pixelated because the pilots have other things to do than just look at pictures of clouds. And the third aspect is actually that we operate these from space, and the vantage point and the advantage of being in space is that you're able to get global measurements, which allow you to better understand what is going on. And even though these are extremely valuable, there have not been that many over the years. So I think I count 5 of them, of which pretty much only one is operational right now. I'll get to the last one at the end of the presentation, if you do not mind. My job actually entails 3 major activities. The first one is actually the airborne science. We have an airborne radar that we actually place in the bottom of the airplane, and it allows you to just measure the clouds that you fly over. We've used it for campaigns around the world, and pretty much we use them in aircraft such as the DC-8 shown here in the left, or the P-3 shown here on the right. Both of these are NASA airplanes. If you looked at them within, in fact, inside them, it's pretty much a flying lab. So it's filled with devices, electronics, and so on. And it is some work. It's really great to be in it to collect data, but it is some work, making sure that the instrument works, making sure that you analyze the data properly, and also trying to do some science out of it. The things that I found really cool is that you get to do things that you wouldn't do in normal civil aviation. The first one being formation flying. So in this case, we're actually in the Philippines trying to compare, the sensors that are on the wing tips and below the aircraft to the ones that were on our airplane. So this is a picture that we took from our airplane, but they also took pictures of us. And the other interesting thing, especially with the P-3, is its ability to fly really low and slow. So this is a picture that we took where we were flying just a few dozen meters above the surface of the ocean. So that was actually in the Atlantic. And when we fly so low, of course, we do not transmit energy with our radars because that might damage our equipment. So that's how I was able to walk up to the cockpit and take this picture. So if I don't tell you that it's an airplane, you might even think that it's a ship, but it was actually an airplane. I'm just flashing this slide to show you the type of science that we do with it. The advantage is being that when you go on field campaigns, you have multiple instruments. So an airplane, a ground-based radar, and in certain cases, you even have an airplane that flies within the targets. And that allows you to do what we call retrievals, or see how you can retrieve geophysical information how much water is there, how big are the raindrops, or how big are the ice crystal from electrical measurements that you get from the radar. So I'm just flashing this. The second project that I got to work on is actually called RainCube. So RainCube stands for Radar in a CubeSat. It was the first radar ever built to operate on a CubeSat. The background behind it is that in 2013, the director of JPL, Dr. Charles Elachi, just challenged the engineer to miniaturize the radars. The reason being that all the radars that existed were relatively bulky in size and also in mass. So it was several hundred kilograms. And the challenge was actually met by Dr. Eva Pera, who is an engineer in the JPL in the radar science section. And she was able to miniaturize the radar, but also use advanced signal processing techniques. At the same time, JPL was also developing a parabolic reflector antenna. It ended up being very helpful. All this effort was supported by NASA through their ESTO technology demonstration program. From the concept in 2013, we moved on to a field campaign in 2015 that allowed us to confirm that what we were measuring actually made sense. So typically, this kind of plot is relatively common in our field, where you have horizontally the distance traveled, and vertically we have the altitude. And pretty much the color tells you information, give you information about what you're looking at. So you can see that the dark blue that you see above 3 kilometers corresponds to ice, and below you see the water that falls, pretty much the rain that falls to the surface. It was amazing to see that even this tiny equipment was able to measure such a feature from the DC-8. They went on and compacted the whole thing, and you can see that overall you end up with a radar that weighs about 6 kilograms and transmits between 10 and 20 watts, which is way less than what traditional radar would transmit. In May 2018, the radar was launched to the International Space Station. And the video that you see here is actually the radar being deployed from the space station by astronauts. And a few moments after that, we just deployed the antenna, which is the video that you see on the left. And it means that if you were able to take a picture of the radar in space, this is what you would see. So this is what we call a technology demonstration. So the aim was to, first of all, build a radar in a CubeSat, which we did. The second thing was to demonstrate new technologies in space. So the electronics of the radar, as well as deploy the antenna. We did. And the third thing, if more important, was to see if you could measure precipitation and clouds around the globe. And this collage of pictures just shows you the number of things that we were able to measure just globally. Some of them are, in oceanic features such as Borneo, where you have some convection and some rain falling. In other cases, we had the interaction between clouds and rain shown in green and mountain, which is what we call orographic interactions. You had other cases where you would be over the ocean and you would see that the height at which ice turns into water is actually slanted. And all this was done using this small radar that fits in a shoebox. The other example that we have was also an overflight of a hurricane. So there was a hurricane getting close to Japan, pictured here from the ISS, and we happened to fly over it. So we were able to get vertical cuts of what was being measured. The prime mission, so initially when we launched, we were supposed to last only 3 months, and we ended up lasting almost 9 times as long. And it ended up being a great success. And despite the end, we were able actually to get another mission funded, and that mission is called INCRIS. It will have actually 3 rain cubes. So it will be a constellation with 3 spacecraft, and each spacecraft will have a radar that is an augmented version of RainCube. So pretty much we built on the success of RainCube. And we also are going to have a radiometer that uses a passive antenna to measure microwaves. I can give you more information, but it was really great for me to go on this because I started to work on the concept back in 2012 when Ziad Haddad, who is pretty much the father of this idea, asked me to analyze ground-based data. And then we moved on to model data. And it was neat to see, that we were able to go from an academic/research project to an actual mission that is supposed to launch in 2026. The last project that I want to mention is actually EarthCare. So EarthCare stands for Earth, Cloud, Aerosol, and Radiation Explorer. It's a mission by the Japanese and European Space Agencies, so ESA and JAXA. And the radar itself is being built by the National Institute of Communication Technology in Japan. You can see that none of these logos is actually the logo of NASA, and that's because NASA is not directly part of it. Instead, we've been able to work on it through a program called the USPI that allows you as a US researcher to be a participating investigator on a foreign mission. And this mission, in fact, is specific because it has 4 instruments, including the first radar that can give you Doppler information. So no longer you will be able to measure where the water is, but also how fast it is falling or being lifted up in the sky. Interesting fact. This radar actually only launched a few weeks ago, and it launched from a place called Vandenberg. So it's a Space Force base that is located between Santa Barbara and San Luis Obispo. And I had already in the past taken the train to go to San Francisco, and I knew that the track of the train would go between the ocean and the launch pad. So what I did is that on May 27th, so the one day before, I just took the train to see if I could get a picture of the rocket. On the way in, I was quite disappointed because the picture I got was this one. So I could see the tanks. I compared, to Google Earth. I could see the tank, but I simply couldn't see any rocket. And we were like not even 24 hours before the launch. Nonetheless, someone actually set up a camera. And the next day, pretty much you can see the rocket over here. I don't know if you have the sound, but able to witness the launch of the rocket. And interestingly, 10 minutes afterwards, a little bit, still the same site. We took off from here. Ten minutes afterwards, we were back on Earth. So that really, for me, was really interesting because what was going on, of course, the rocket was launched by a SpaceX Falcon 9, and it turns out that they actually erected the rocket about 6 hours before launch, which was something that I did not know. The video that I showed to you was actually taken by Pauline, who is a professional photographer and who knew exactly where to be. And with this collage, you can see that she was able to get a picture of the rocket going up and then coming back down. This is a video of the spacecraft being released, and then a few hours later on, they opened the antenna and deployed the solar panels. They did the other way around. And the fun fact is that while I was coming back by train, I was this time able to get the picture of the rocket after it had landed. I just want to close with this slide. This is mostly intended for current students. I just wanted to say that I had an amazing time at ENAC. I cannot say enough how much I enjoyed my time there. I enjoyed my time there because of the people that I got to meet. And to this day, we're all friends. You can see it on this picture of our reunion that happened in 2022. It was really awesome. We got to play some soccer in the afternoon and then dance in the evening. And I can tell you that we all still get it. So killers on the field and killers on the dance floor. I also want to thank the class of 1999. You can see here Vincent, who was the captain of our soccer team. And they did an amazing job of welcoming us. And that made a huge difference. They were welcoming, really nice, and also encouraging when we were facing a little bit of difficulty. So I really want to thank them for that. The next thing that I want to say is that the curriculum that we have at IENAC is really exceptional. We get to see a lot. And the things that we see can really come in handy down the line. So the one piece of advice that I would give is to just keep your books and your notes. The Alumni Association has been extremely helpful for me because in my case, I need to know why I'm doing what I'm doing. And it turns out that being able to talk to alumni gave me just that type of information. Traveling internationally was extremely helpful for me, and I strongly encourage you to do so. There are different opportunities. You can do an internship, you can do a PhD or a postdoc. If you consider JPL, though, you would need a scholarship of a grant of about $2,400 a month. I know that our friends at Supero have a foundation that actually grants scholarships like this, and quite a few of them actually come to make an internship. So I don't know if ENAC can have a similar system. And if it doesn't work for JPL, there are many other institutions that I'm listing here. Again, thank you very much. I'm sorry I went a little bit long, and if you have any questions.
Thank you. Thank you so much, Ousmane. It was super interesting. And yeah, I know the feeling about the Netherlands and the rain. I've been here for about a bit more than a year now, and I'm starting to also feel it, but yeah, very happy. Thank you so much. both of you. It was super interesting and really nice to see the pictures also from you, Sid. I'm really impressed that you kept them. Even Nicola and I were ENAC 16, and even now I think we start. Well, on my side, I started losing some of my ENAC pictures already. So really great that you could show them. Now we are going to go do the question round, and we have identified 3 main themes that we want to talk to you about. The first one is career choices. So maybe, yeah, Nicola, go ahead for the first question.
So yes, we noted that you both conducted a PhD during your studies after ENAC. So Sid, it was at Paris in 1994, and Ousmane in the Netherlands a bit later. So do you think that the PhD is something mandatory or a good advantage to work internationally and specifically in the US?
I can start, or Ousmane, you might want to take this one first.
I know you can go ahead if you want.
Okay. So my answer to that, I would say it really depends on your plan for the future. If you are into the science or the research, a PhD is really a must, I would say. But if not, then it's not necessarily a necessity. I had an experience actually when I was in Boston in that private company. They hired at one point a librarian, and she was so good in terms of communication, in terms of interpersonal skills, and so on. And she ended up being the vice president of that company within just 2 years. So in the US, at least, PhD is not necessary. But it is a must when it comes to research and science. So it really depends where you plan to have your career and in what field you wanna have it. So that would be my my answer to that. What I would add also is that with time, your degree is not necessarily what matters the most. It's your entry point. If you have a PhD or a master, it might give you access to certain fields faster, and it opens the doors for you. But after 20 years or 30 years, that becomes less and less important. I've had colleagues of mine who did not have PhDs that ended up being really great scientists and published a lot of publications. So that is my it depends answer to you, Nicola.
Okay, yes, I see.
Maybe you,
I would say,
Ousmane, you
yeah,
want to compliment? Sorry, go ahead.
exactly. I would say actually exactly the same. The one specific thing that I would add is that especially if you work in aerospace, because it's an area that is so close to defense still, you know, having a PhD, for instance, in my case, I don't know that I would have been able to come to the US because I didn't have a US citizenship. So it meant that I couldn't work for the longest time on anything related to hardware. Instead, because I had a PhD, I was able to come here and do a postdoc. So it was just pure science. And the science done at NASA is science that is pretty much open to everyone. So in my case, I know that it was really helpful. But as Sid mentioned, in fact, that really depends on what you do. If there are people who are, for instance, have a bachelor degree or a master's degree in whatever they do and seem super happy. So it really depends on what you want to do.
Okay,
thank you.
So if we sum up, if you want to work in engineering in the US, in the space sector, you will probably work with the defense. So it's difficult if you don't have the US nationality. But it's easier to work with the science, and so getting a PhD is useful, right?
Exactly, because the entry points to do science are either as an internship, but you know, after a master's degree, you probably want to work instead of doing another internship. Whereas if you have a PhD, you can come in straight as a postdoc, which is something that is pretty common at JPL. So that's my experience. Maybe other people think otherwise, but that's what I've experienced.
Okay. Thank you both so much. Now I wanted to get a bit deeper into your path, Sid. So we can say that, as you said, well, you joined NASA only about a bit more than a year ago, so you're kind of a newbie for NASA. I wanted to ask more about the fact that you worked previously in NOAA, National Oceanographic and Atmospheric Administration, for 18 years. How was the switch for you going from NOAA to NASA, considering that, okay, basically they're both governmental agencies for the US, but maybe there are also quite notable differences that you already feel after 1 year at NASA. How did you feel with this change?
Yes. So we both deploy satellites, we both operate satellites, we both exploit satellites, but the culture is completely different. NOAA, as I was explaining before, is the agency in charge of operations in the US. They issue forecasts, warnings. So lives and property are on the line for NOAA. Their satellites, they have to operate at 99.99% reliability. And that's the number. I'm not making it up. So that has an impact on the mission, on the culture of the team, on the ways things are done and perceived. It's more sober, it's more mission focused. No error is allowed. So they are very conservative. NOAA is very conservative for good reasons. In NASA, the mission is different. It's about really exploring, innovating, finding the next new thing and the next breakthrough. So failure is part of the deal. It's part of what we do in NASA. It's part of the path to excellence. So yeah, there are differences because of that, because of the types of the missions. Even if both agencies deploy and operate satellites, like I was saying, but I would say also that they are complementary. Many of the satellites and the observance systems that NOAA has for its operations started as actually innovative missions from NASA. And then they got transitioned to NOAA for operational maintenance and so on. And similarly, we in NASA rely on NOAA for the long-term sustainability. Like, let's say, NASA does innovation on a regular basis. So it doesn't want to be burdened by things that are for sustainability for the long term. So when something is really important, like for monitoring climate change, we rely on NOAA to transition those missions so that NOAA can do them on a regular basis and in a sustained fashion. So very different missions, different approaches to how we do business, but at the same time, very complementary. I hope I answered your question.
Yeah, no, it's very clear. Thank you so much. A very interesting answer.
Yes, thank you. And so now that you're working at NASA as a senior program scientist, what is a typical day for you? Like, what do you do in your daily work, and what's the most exciting activity you're taking part of?
So as a strategist in the NASA Earth Science Division, one of the first things, believe it or not, is to when I talk to outsiders, is to make them aware that NASA is more about is about more than the moon and the Mars, because that's what people think of when they think of NASA. We also do the monitoring and the observation of our what we call our favorite planet, Earth. So there is a lot of sort of awareness that happens, but also the strategy that we are working on right now in its implementation comes at a time that is extremely important. I'm not sure if you're familiar, but the global change that is going on, it's not just climate change. It's climate change, it's biodiversity change, and so on. So we are working on trying to find a way to provide actionable information to stakeholders, to users, to people who are taking actions on the ground so they can make those decisions to address the aspect of climate change and global change. So really the exciting part of last year's work in NASA is to work on that strategy that we call Earth Science to Action strategy. So we have to think about Earth system as a system of systems, because the environment impacts the humans impacts the environment, biodiversity is part of that. How does that impact agriculture, water resources? So there is this analytical thinking about how do we function as an overall Earth system. And believe it or not, that's the exciting part for me. That's what I like, what I have been liking doing the last year in NASA. There is also the other aspect of, hey, there is artificial intelligence going on. There is digital twin technology going on. How do we take advantage of that? How do we take advantage of observance systems that complement satellites, drones, devices on cars, devices in houses? There's a lot of work going on to take advantage of that. And I will finish by just saying one thing, that some of us are kept awake at night because of that, which is geoengineering. More and more people are talking about doing something, not in terms of mitigating the climate change, but in terms of actually reversing it. So doing something to remove the CO2 from the atmosphere, or reflecting the sunlight back into the space. So people are thinking about techniques to do geoengineering to reverse the effect of climate change. That forces us to think about how to provide the scientific information for people who are doing that, in order to do it with scientific basis as much as possible. So these are the type of things that we think of, and take much of my time as a strategist in NASA Earth Science Division.
Thank you so much,
Thank
Sid.
you.
That was a very interesting answer and insightful. Now I have a question for you, Ousmane. It's a bit of a similar question. We wanted to do with Nicolas. Okay, you have been working for NASA GPL for 15 years now. What has been the most exciting mission that you worked on, according to you? Maybe it's Earthcare, because I know that you mentioned it in your slides. And I have a colleague actually who was involved in the LEOP, and I know that it went him through sleepless nights. But
Yes.
yeah, maybe you can comment on what was your favorite mission so far.
Oh, thanks for the question. So you would think that it's Earthcare because I've been working on it for many years. But so I loved, don't get me wrong, I really loved working on it, especially because it involved an international collaboration with Japan. So I got to spend 3 months with Japan, make actual friends, and it was really interesting. But I would say more RainCube, and the reason being that initially I was involved in an initial study where we used the ground-based data from NOAA, from NOAA NextRad radars, to see if you could get a signal. So there was no guarantee of success. We were still able to detect something. And it just so happened that at the same time, they were developing this radar in a CubeSat idea based on a challenge. So, in that sense, I feel extremely fortunate, because had I been here 10 years earlier, I don't think that I would have had a similar experience. So that was really neat. And with the CubeSat missions, you're able to see it, from beginning to end in a relatively short amount of time, because the platforms are simpler. So, I was able to pretty much process the data that the radar first sent to the ground. So that was really exhilarating. And I was also able to be there, at the end of the mission, and then write a paper about all the things that had been measured. So I would say it would be RainCube, just because you could see from beginning to end. And the last thing that I would add is the fact that we have now another mission, a follow-on mission in Incus that is planned as a follow-on of RainCube. So you get to see not only the mission, but also what it led to afterwards. So that would be my personal favorite.
Yeah, very nice. I also think RainCube was really interesting from your slides and the pictures. It actually really seems very cool. Thank you. Nicolas, you want to do the next one?
Yes, so we noted that so you both work in the field of space remote sensing, which is one of the space areas with the most direct benefits for life on Earth, and in our current context of global warming and environmental crisis, what do you think of the other space activities, like this deep space exploration and sending people back to the moon and maybe one day on Mars? Do you think it's important today, or it's something not really in the right time?
Tricky question.
You want to go?
We don't want to put you in trouble.
No trouble at all. Go ahead, Ousmane.
No, I mean, my answer is going to be short, because in my case, the curiosity aspect of us is what makes us unique as humans. And I think exploring beyond our Earth is a really key component. Okay, you need to be smart about how you do it, but when you think about the challenges, like a Voyager launched in the 70s is still sending back signals from interstellar space. Just think about that, And then there's a lot to do on Earth, and of course we need to take care of our favorite planet, as Sid put it. But I think that the exploration beyond our Earth is an important thing. That's what I think. I don't know what you think, Sid.
Yes, similar. But first, I have to say, for space remote sensing for the Earth, we still have to demonstrate value to society and the public every single budget cycle, despite the fact that, yes, it has benefits to society. But like Ousmane was saying, I have to tell you, I'm like everybody else. I'm really excited about despite having spent much of my career in Earth-centered space exploration, I'm really excited about the deep space and the potential to go to the moon and to the Mars. I think there's something ingrained in us as humans to explore and go beyond what we know. But there are also, I think, practical reasons why this is important. If you look at history, the deep space exploration, we benefited from it in the Earth observation. The technology that was developed for deep space benefited the Earth observation. There were a number of science breakthroughs that came from that. Nowadays, the biology in outer space, there is a whole division in NASA about that. We benefit from that as well on Earth. So there is a feedback loop that comes to benefit us on Earth that I think, practically speaking, it has a dual use: deep space exploration, Mars and moon exploration. But at the same time, it has some benefits that come back to us. So I think it's all good. And I would also add one thing, which is for the aspect of heliophysics, when you explore the sun behavior and so on, that has also a direct effect on the weather on Earth.
Mm-hmm.
So our power grid depends on that, communications, and even our Earth-looking satellites depends on good knowledge of the sun's behavior.
Well,
Awesome. Thank you so much.
Yeah, thank you. I think I agree, and I think it's also a way to keep people interested in the space activities with something as amazing as the Artemis program, so that people can think about space careers and then work in the space sector. Thank you.
Yeah, fully agreed. Thank you so much. Last question on the theme of career choices and really looking at the interactions, also the collaboration that you have as part of your job. We wanted to ask a question on your collaborations with international space agencies, whether it is at really scientific levels or policy decision-making levels. What are the international agencies that NASA collaborates with the most in the domain of remote sensing? And how important, and also a follow-up question, sorry, is how important do you think this international collaboration is for the domain of remote sensing and Earth observation?
I can start. Ousmane, I can start.
Go ahead, yeah.
I was going to say international collaboration is absolutely critical for what we do. For obvious reasons, there's no country that can do it all and do it very well. In our strategy that I mentioned in the past, the Earth Science to Action strategy, that partnership and that international collaboration is actually recognized as one of the strategic goals, sort of one of the principles that we will be adopting in order to do what we need to do, because it's a global challenge. Observing and monitoring and predicting the Earth system, it is essential that we collaborate. And it is collaboration at multiple levels. It's not only how we deploy the constellation of satellites, so they are complementary to each other, but it's also in terms of exploiting the data and sharing the science to extract the information and be able to accurately predict the Earth system in the future. And because of the interconnectedness of the system, nobody can really do it entirely by themselves. One event in Siberia could have an impact on the west coast of the US. So having a monitoring that monitors the Earth system everywhere all the time requires that international collaboration. So naturally, the US and NASA has a natural partner in the European Space Agency, ESA, and that is something that is critical for us, and we work with them a lot. We have a strategic partnership with them, but we also work with space agencies from Japan, from Korea, CNES as well. And we work either through bilateral interactions or through international bodies like the United Nations WMO organization or the Committee on Earth Observing Satellites, the CEOS, for example. Ousmane?
No, absolutely. I absolutely concur. And then the other funny thing is that actually the target that we're studying, at least when you're studying the weather doesn't really care about the boundaries. You know, the weather that you have in front. So, for instance, the example that really struck me is that, for instance, the hurricanes that hit the east coast of the US, many of them are actually born through waves that go over the Sahara. So you have a lot of work that goes on. And for instance, the picture that I took of our 20-year reunion, I actually took a break within a field campaign we were in Cabo Verde in West Africa, studying exactly that. Why is it that some of those waves carrying some aerosol from the Sahara end up being catastrophic, leading to catastrophic measures? And why is it that others just die out over the ocean? So that's something that is still open. You see that to know what is going on, you pretty much need to measure what happens everywhere. And exactly as Sid said, in fact, we are in a situation where we have way more unknowns than we have constraints. So the more ways you have to constrain, the better it is. And one way is actually through international collaborations.
Thank you.
Okay, thank you. So if we're talking about other space agencies, we would like to ask you, why did you choose to go to work for NASA and not staying in Europe, for example, than work at CNES or ESA or another agency? Are there lots of differences between the European and the American mindset in the space sector? What made you make this choice?
If I may, in my case, the thing is that when I actually graduated in 2003, and in 2003, the economy was not that great. So for instance, the companies like CNES or even Astrium, back then were not hiring. At least if they were hiring, it was just a handful of people. So that was one of the reasons. And then after those 4 years in the Netherlands, as Maëlys confirmed, yeah, I just needed to go somewhere a little bit sunnier for a few months. So that was my motivation. And the other thing is also that I think the application period was relatively closed. So if you want to apply for a postdoc or even mostly for a postdoc at ESA, there is a window during which you can apply. Whereas the offer that I applied for in the US was available when I was looking for one. So that's how I ended up coming here. Is there a difference? There definitely is. So you're still working in space. The targets are pretty much the same, but I would say that the authority that is above you is different. So at CNES, it will be mostly the French government and pretty much what goes on in the French industry. If you move on to Europe, all the member states or the main stakeholders need to agree to whatever is happening. So you see that it's a different kind of constraint. And in the US, it's an even different situation because Congress needs to vote for the budget. And it's pretty much, the connection to the politics in that way is definitely there. So in my view, that's the main difference that I see. Maybe it's something different.
Thank you, Ousmane. I think it's similar. I mean, in my case, it was really by chance I ended up in the US to start with. So I'm afraid to say that was not a well thought out plan that was well executed, and I ended up in NASA. I just had a poster in Boston while doing my PhD, and it happened that somebody there had a proposal with the same title, and he offered me a job if he got funded, and he actually got funded. So I ended up in the US working there. And because it was in the field of remote sensing, you end up, after many years, it's a small community. So you end up knowing people from NOAA, from NASA, and people move around, and you end up having your network of connections and so on. And it happened that actually the head of the Earth Science Division in NASA was a person I worked with in the past in NOAA and in the NPOS project. And so that was a great connection to have, and I was aware of the opportunities there, and I ended up working in NASA. So it was by chance and circumstances. Now, why choose NASA and CNES? Because there is potentially an option to go back to Europe and so on. I think you get used to the US model. I don't know about you, Ousmane, but the melting pot in the US is a real thing. And for some of us, perhaps non-native of France, it feels good. It feels really like you are a fish in the water, and it is a great place to feel like comfortable all the time, everywhere, even when you go outside and do your business. So that's the attraction, and of course there is the everyday life when you have your kids here and they start going to school and so on. You get you get accustomed, and you think of the family aspect as well.
Absolutely.
Okay, very great. So I understand for you is more or less a chance. It was like something random. You went there by chance, and maybe Ousmane for you is also more about the weather. But okay, in any case, it was not a well planned
No,
path to go to the US. Yeah, very nice.
no, but
Now
again, also,
yeah,
I
sorry.
think the attending conferences really helped me because I got to come to the US twice. So you get, an idea of what it is like. And then maybe you want to know more, or maybe you don't want to know more. So I'm sorry I
Yeah.
interrupted you. Go ahead.
No, no worries. And I was going to say that now we can step into the last part of the questions from our side, from Nikolai and I, and then we have the questions for people on the chat. I see that you're already answering the questions, so so maybe we won't have anything to discuss at the end of the webinar. That's really amazing. You are very super guests. So we enter into the part looking into the future, and we had questions on, of course, this is the hot topic at the moment, is AI, artificial intelligence, to be used for remote sensing. So it's clear that AI is a vast area of interest for the domain of remote sensing. You can use it for analysis of large areas of interest, classifying objects, detecting land use, data fusion, cloud removal, and so on. We were wondering, to what extent is it currently being used in NASA programs, and how do you see this evolving in the future? And there's just one thing I would like to add is also, I know that Sid, you particularly worked on the topic because you even received an outstanding contribution by the American Meteorological Society Committee on AI. So, okay, we are expecting to, I guess you have a lot of insights on this question, but both you and Ousmane, we would love to hear your thoughts on these questions.
Okay, if that's okay with you, Ousmane, I can start.
Absolutely. Absolutely.
I would say AI now is almost part of everything we do, from the calibration and validation to remote sensing algorithm to emulating forecast models. So the entirety of the value chain of exploiting satellite data, AI is now playing a role in it, either in the research mode or literally in operations. But I want to perhaps bring your attention to something that I think is really important, which is the foundation AI models. If you might remember, in the beginning with Google and other big companies, they started having those face recognition algorithms. And those are based on foundation models that are trained on massive amount of images. And then all you need to do is change the last layer of the AI algorithm to make them applicable to either face recognition of humans or cat recognition or house recognition and so on. The same thing is happening in our field. There are foundation models, AI models that are being developed for the science of the environment, and they could have really massive implications down the road, because it will make it a lot easier for anybody to fine-tune those foundation models and apply them to cloud recognition or sea ice recognition or algorithms for different geophysical parameters. So there is that aspect of foundation models. And I think now we are past what I call the trauma phase of AI. At one point, people were so shocked that AI could be doing anything because it's just a bunch of statistics and regressions and so on. It's no longer the case. People are realizing that with the explainable AI, XAI, you could take advantage of the benefits of both worlds, training based on observations, but also infuse physical constraints in your training. So it is more and more adopted, more and more accepted because of that reasons. So I think going forward in the future, it is going to be a combination of foundational pillar. AI is going to be a foundational pillar of what we do, but living in parallel with the physical models. It's not one or the other. It's both of them living side by side. That would be my take on this, Ousmane.
Absolutely. I mean, I absolutely concur. So in my case, my experience that I had is that in all the field campaigns, I'm in charge of actually the data processing. And in that it's just the volume of data that we call it is so massive that at some point you either get tired, looking at the same things again and again and again. And there's a number of patterns that you see that your brain can detect, but a simple logic couldn't. So, having, in fact, a smarter way of sifting through the data, getting robust signals, and then acting upon it is really a great thing. And I would totally concur as to the trauma the thing that people, because it's new, at first people were a bit, wary or wondering, okay, and it's artificial. What do you mean artificial? But now that people have seen all the benefits you can get from it, it's I think it's a key component. So from the people that I know around me, some actually work with people at Caltech, so it's more research oriented. But I can tell you that from the practical point of view, it's a key thing. And actually, another aspect where it comes in handy is if you try to have a platform that does not have a human in the loop. So just imagine that you build a radar and you put it on a UAV, or you build a radar and you put it on a high flyer where you simply only have a pilot. You would need to have some sort of a smart way of deciding when and where to use what type of signal. So in that framework, I think that AI is a key component.
Thank you both so much. I'm very happy that we passed the era of, as you say, of trauma, and that we can already use AI for remote sensing and also other space activities, because I think it's really a great tool for everything that we do in space. Thank you.
Yeah, thank you to both of you. And on the same subject, are you thinking about other future technologies that could disrupt the world of satellite remote sensing? Like, what do we have to expect from the future?
So I would say, of course, this is speculation, and the beauty of speculation is that you can say anything and nobody can validate it or invalidate it. So in my mind, what I'm seeing is that there are two things: the hardware aspect for space and the data exploitation aspect of things.
Okay.
In my mind, for the hardware, quantum sensing seems to be something that will really revolutionize the way we measure the way we do remote sensing. There is a leap in the quality of what we can measure from space with quantum sensing. On the data exploitation side, you have to remember one thing, which is there is an explosion of data, not only from satellite, because you have hyperspectral, high spatial resolution, high temporal resolution, and you have all the devices going on the ground, from houses, cars, fridges. All of those are becoming sensors that you can take advantage of to do remote sensing. So the data exploitation aspect is going to be massive. So AI is going to play a role, no question about it. But I suspect that as we move forward, something is going to happen with the gaming industry, because the gaming video industry has done so much in terms of actually collecting data, making it high resolution, and allowing people to test. Okay, if I play with this player, if I do this, if I build this farm, and so on, that is what we do. That is what people are eager to see on the remote sensing side. What happens to my area, to my house, 10 years from now, 20 years from now, in terms of flood risk and fire risk and so on. So I suspect that at one point there would be an emergence of video gaming capability that will help us exploit the enormous volume of data that we have in remote sensing. And I will stop there.
Absolutely. Absolutely. The other thing that I've been seeing is mostly as JPL is also the fact of using smaller sensors. It was funny with RainCube because I got to see it, but you have other sensors in the pipeline that will use different frequencies, different remote sensing techniques, but that fits, in a smaller platform. So it means that the way that people had of thinking of space as being, weight is heavy, weight is expensive, being heavy is expensive, is no longer an impediment, because you're pretty much able to get a sensor that is relatively lightweight compared to what existed. And with it comes what we were saying earlier. If you deploy multiple of these, you also need to have a way of flying information, keeping the constellation, in fact, in sync. And all this leads us back to essential applications of AI. So that's the thing that I would see.
Thank you both so much for these insights on the new technologies and the new disruptors that are coming in remote sensing. Now we would just like to finish up our round of questions, and then we let the floor for the audience. And our question is more targeted to students today in ENAC. Imagine when you were yourself back as a student in ENAC. What advice would each of you have for ENAC students who wish to embark on a career in space, and in particular perhaps space in the US?
let me take this one if you want. So
Right.
the one thing that I would say is just take advantage of the life on the campus. There is something about the population of ENAC because it's a big school, but we're not as many as we were, for instance, at Eindhoven. 14,000 people, you just don't get to know people as much. And then with that, I would say that the quality of the classes that we get is pretty high. And there's just one difference that is that in France, usually they expect you to come from a school that has aviation or space in its name to work in the field. But that is no longer true once you cross the borders. So for instance, in the Netherlands, what they'll ask you is, okay, what type of skill do you have? Are you good at applied math? Are you good at computer science and so on? And then if you have those skills, you can come and apply them to the field of space or aeronautics. And in the US, it's also a little bit like that. They have, of course, their big universities, but I don't know, okay, maybe Embry-Riddle is the exception, but I don't know many graduate from that university here. So pretty much just, own your skills. If you have internships, just, use that as an opportunity to explore the field. And as I put in the last slide of my presentation, there are many opportunities. So if you see something, don't hesitate to apply. I'm not saying that the answer will be yes, but if you do not apply, the answer will definitely not be yes. So that's what I would say.
Yeah, just to add quickly to that, I'd say pay attention to your internship. Your stage de fin d'études is probably your entry point. If you want to go to the space field, that would be a perfect place to start. So choose that judiciously. If you're interested in science and research, at least as an entry point, I would highly recommend considering a PhD or master or both. And there are many institutions in France that offer those opportunities. I would say take advantage of your closeness to CNES. Go there, meet people, make connections. You would be surprised how many things happen just out of random conversation, having lunch or sharing a sandwich or anything. Make connections. That helps a lot in terms of, again, the entry point to your career. So along the same lines, build relationship, attend seminars, ask around, just simply ask around randomly. You have nothing to lose and you have a lot to potentially win. And I would add the last thing would be check online. A lot of things happen online. There is perhaps the other problem, which is it's massively online, and therefore it's sometimes intimidating. But be patient and search methodically the websites that you're interested in. NASA and NOAA. There's another agency in the US called the USGS for the land aspect, and also in other countries. A lot of information are in there, and remember the rule of the 1%, meaning that somebody told me that in the past, and that was very useful as a mind frame. If for every opportunity you have to apply 100 times, so don't get desperate if you don't get an answer after 10 or 20 or even 30. You have to reach the 100 in order to get one opportunity. When you have that in mind, it gives you the courage to continue and to persist. Anyway, so that would be my recommendations.
Thank you so much. I really love that last advice of the 1%. I think everyone here will definitely remember it. And if you want to go to the CNES, you can send a message to Nicolas. He will be happy to share a sandwich.
Yes.
I am sure.
Yes, but I totally agree with your advice. When I was looking for a summer internship, I applied to many companies in Europe, in Denmark, in Great Britain, and in the end, I got an internship in Germany at Airbus Defence and Space, and the internship offer was written in German, and I didn't even speak German, but I tried, and in the end, it worked because everybody speaks English in the space sector. So they said, oh, it's not a problem, you don't speak German. So I really agree with this advice of apply to anything you want, and you might be surprised. You might get an interview and get an internship or a job somewhere you didn't expect. So yeah, I think it's a great advice to everyone. And yeah, we have lots of internships at CNES and lots of great subject, great activities. So if you're interested in CNES, you can you can ask me. we will jump to the question from the audience. We have a few questions.
Yeah, I can
that
ask the first one if you want.
Yeah.
Sure. So I
Yeah,
think,
go ahead.
Sid, you already started answering it, but it's a question from Mikael asking, what is your point of view about the debris impact on Earth observation? For both of you.
Yeah, my answer is in the chat. I think that's a real
Yeah.
issue, and it's being compounded and increasing in severity. But I remain an optimist person because I'm seeing that there is an actual industry that is popping up in order to address this issue, with people being very creative in actually going into the space and cleaning literally the space from the junk that's out there. So it is an issue, but I think smart people are working on it.
Okay, great. And I think Mikael also has a startup working on exactly that. So very great. Thank you for the question, Mikael. Ousmane, did you want to complement? Sorry.
No. I think it's great, but I think that also what helps is the part of using reusable rockets. So the SpaceX rocket that was launched to launch Earthcare. The fascinating thing to me was that it came back. So that's one less thing to worry about in space. And I think the more you'll be using reusable technology, I think the less you'll have issues related to debris. That's all I.
Okay. Yes. Thank you.
Nicolas, you want to ask the next one?
Yeah, there was a question about whether you had issues with your visa or passport in your career. So I think, Ousmane, you mentioned that in order to get, for example, an internship at JPL, you have to show that you have a certain amount of money with yourself, but they don't count sponsorships, right?
So I think they count that. What they will not accept is, for instance, help from the family. So you need to have like a grant or an.
Okay. You have to get a grant, like
exactly, and that's why I'm mentioning it, because I know I often meet actually interns who come from Superior or other French universities, and in their case, the foundation actually provides a grant for the duration of the stay. So that's why I was bringing that up, because I've received quite a few applications from ENAC, and in terms of curriculum or what they do, it's fascinating each time. But because of that condition of the internship, that's why I always have to divert and tell them, okay, try Caltech or try somewhere else, which I think is a pity, because there's a lot of very interesting things going on here, and I think we're pretty well equipped with a ENAC or ENAC curriculum.
Okay, yes. So yeah, it's the way it works in the US. So we have to comply with it. And if you want to go to do an internship there, you have to show that you have a grant for this, and not only the money on your account, on your personal account. Okay.
Yeah.
If I can add one thing quickly, because you can come to the US not only as an intern, but you can come actually out of school to start working. And because there's the H-1B visa that is also a possibility, professional visa. And my advice there is work with a lawyer, because it's a lot more efficient in the US if you go through a lawyer than if you try to do it by yourself.
Okay. Thank you. That's a good advice. I hope this answers your question. I don't know who was asking it, but okay. Thank you, Katib. Thank you so much. And we have actually a two-part question from Maria. The first one is, she's asking, when NASA is often associated with space research, what significant contribution has NASA made in the field of aeronautics? I don't know.
Many.
Yes, indeed.
Many. I mean, right now I think they have a lot going on in terms of future supersonic flights. So that's one. We happen to be in the remote sensing, but there are many other centers where they develop very interesting things. So I think the flying wing is one of them. I mean, it's I would say many. Where do you want to start? And you also have a huge part that is related to the ATC aspect. Having a fleet of aircraft and then being able to monitor them. So I would say many.
Yeah, I don't have much to add there. Then it's not necessarily my field, but to say that there is a major effort to create the next generation airplane, actually supersonic airplane, that NASA is working on. And my understanding is that they are going through some of the last phases of getting approval for that. So more information could probably be found online, more than I can probably provide.
Yes.
Thank you both for the
Yes,
answer.
indeed. We have to remember that the first A of NASA is aeronautics. So
Yes.
lots of research on aeronautics.
Yeah.
We have a question from Hugo asking what kind of
Wait,
book
because
do
we
you
had the second part of the question for Maria, Nicola,
I'm
which is
sorry.
okay, maybe no worries. It's maybe I think it's an interesting question. So let's see what Sid and Ousmane think about it. It's considering that the ENAC engineering training program offers limited courses related to space. Does this indicate a need for more technical training and specialization in space at ENAC for people who might want to join the space sector after ENAC?
I think that's a nice suggestion, a nice thought. But that would obviously depend on ENAC's strategic objectives and direction in the future. It would make sense, in my opinion, but it is really a question for ENAC. If we want to target that.
Yeah. And again, what I would say is that my experience is that we see a lot at ENAC. We might not go deep, in the nitty-gritty or the details of it, but I mean, you're just taking computer science and things that we see. So for those who do the equivalent of T, you have aerodynamics, electrical engineering. All those are things that are present in spacecraft. So just because the title, of the book that you have or your lecture note doesn't say space, it doesn't mean you cannot use that for space. So.
Exactly. And I think I fully agree with that, because I think, okay, you can come to space by having done an aerospace engineering program, or you can have you can come by having the electrical engineering or telecommunications engineering. Both Nicola and I, we did telecommunications, and then Nicola also, to complement that, he did also an exchange in Italy to have a more aerospace engineering add-on. And in my case, I did fully telecommunication in ENAC, and now I work in GNSS for the European Space Agency. So whatever your background is, it doesn't really necessarily have to be fully aerospace engineering. But if you do something very technical, you can always find a way in space. Yeah, I agree with what you both said. Although it can be interesting to have specific courses, but it's not mandatory. Nicola, sorry, go ahead for the next question.
Yeah, no, sorry, a question from Hugo asking what kind of books do you read?
That's an interesting question. And the reason I'm saying this is an interesting question is because recently in my new job in NASA, I felt the need to train myself in an area that I was not trained on. Because as a scientist or as an engineer, you get focused on the technical aspect. At one point in your career, and mark my word for that, you will need more than the technical aspect. You will need the communication aspect, the leadership aspect, how to convince people, how to coalesce. The human aspect is something that we are not necessarily trained on, at least in my previous education. So that's what I'm reading the most. And actually reading is probably an exaggeration. I actually more listen to podcasts than read actual books. So I listen to podcasts in my commute, and they are more about how to collaborate, how to coalesce a community, how to get into the power of conviction to others. Those are the type of books I'm reading, unfortunately. There's nothing really, it's actually fun for me, but not necessarily in a general sense.
In my case, actually, I felt the need to go back to literature a little more. So I've been reading some of the novels that I never got to read earlier. I'm also trying to read in English, which is really interesting because the references are a bit different compared to what we had when going to a French school. And on a lighter note, actually, for my birthday, which was a few months ago, I got offered a book by Kobe Bryant, which is The Mamba Mentality. And given the fact that I'm in LA, it's an interesting read. You can't read it cover to cover. It's almost like a dictionary. You go page by page, like, okay, what did you do in this situation? And get information out of it.
Okay, so inspirational book, The Wood by Kobe Bryant. Nice tip for all of us. Thank you so much. I don't know. I think we wrapped up the round of questions from the audience, because the next ones are specific to CNES. I think we're talking about CNES. We generated a, a chain of questions. As well, if you want to answer some of them now, Nicola, or we take it offline.
Yeah, I'll answer them in the chat, or you can contact us with our emails, which are first name dot surname at alumni.enac.fr. So it's
yeah.
So it's easier.
But yeah, to wrap up this webinar, I want to give a big thanks to Sid and Ousmane again for joining us. I think we all had a really nice time.
Yeah.
We learned a lot. I think everyone in the audience really appreciated your presentation, and I'm really happy that we made it happen. So thank you so much for supporting us, and just in general for the people listening, if you want to have a specific topic in the next webinar of the Space think tank, contact us per email, and we can find we can gather your proposals and maybe take one of the topics for the next webinars. So thank you again so much to Sid and Ousmane, and have a great rest of the day.
Thanks a lot,
Thank you.
Sid.
Thank you.
Thank you very much.
Thanks.
Thank you, everyone. Goodbye.
Bye.
All right.